Welcome back. We're going to continue evaluating algebraic expressions by looking at a few applications. Let's say we want to find the area of a trapezoid. A trapezoid looks something like this. Something like that. It's not really drawn to scale, as you'll see in a second. The area of a trapezoid is given by the equation A for area, equals height divided by 2. H is for height. This is the height, the distance between this shorter line and this larger line, multiplied by A plus B. And A plus B are actually our bases, this longer line and this shorter line. One will be A and one will be B, depending on how they're defined. And we're going to define these bases as A equals 10 centimeters and B equals 16 centimeters. So this line will be 10 and this line will be 16. Again, not quite drawn to scale, but we're going to work with it anyways. And we're going to define our height as 6 centimeters. So the distance between these two bases is 6 centimeters. Now, we learned in our previous video on evaluating algebraic expressions that when we know the value of the variables, we can find out the value of the expression by simply plugging in the value wherever we see the corresponding variables. So let's go ahead and do that. Okay, so we have the area of the trapezoid is going to equal height, which is 6. Remember, when we substitute values in for variables, we put them in parentheses just for clarity, divided by 2, times A plus B. Well, A is 10, plus B, which is 16. Close parentheses. Okay. We can actually go ahead and take care of this outside, even though the order of operations says take care of what's in the parentheses first. It really doesn't matter. We can do both steps at the same time and it wouldn't affect anything. 6 divided by 2 is 3, times 10 plus 16 is 26. 3 times 26 is 78. Okay? The area of this trapezoid is 78 squared centimeters. Okay, that's not really important here. It's actually the units, which we can get familiar with later on. But this is, I want to be sure you get evaluating algebraic expressions by plugging in the value for the variables. And the area of the trapezoid is actually 78 square centimeters. Let's do another one. Let's look at our next application. Let's say we're dealing with electronic components. The total resistance of two electronic components wired in parallel is given by the following expression. We have R sub 1 times R sub 2 divided by R sub 1 plus R sub 2. Okay, these are resistance for R. And resistance is actually given in ohms. Okay, this is just the fancy word that it's the unit for resistance. You'll learn about that in physics courses, which we might do a course on physics later on. But for now, we're going to find the combined resistance of these two wired components. That we're going to say the individual resistances are R sub 1 is 25 ohms, and R sub 2 is 10 ohms. Okay, so the resistance of the two wired components, R sub 1 and R sub 2, is 25 ohms and 10 ohms respectively. Well, what we learned is, in our algebraic expressions, when we're evaluating, we plug in the value for the variables. So wherever we see R sub 1, we're going to plug in 25. And wherever we see R sub 2, we're going to plug in 10. So let's go ahead and do that. We have R sub 1, which is 25. We always put them in parentheses, times R sub 2, which is 10. And that's our numerator. Denominator, we have R sub 1 again, which is 25, plus R sub 2, which is 10. Okay, and we also learned when we're evaluating algebraic expressions that we can treat the numerator and the denominator at the same time, even though they're going to be in different steps in the order of operations. So the numerator, we have 25 times 10, which is 250, and 35 plus 10 in the denominator, which is 35. Okay, and we can go ahead and let's go ahead and change this into a mixed number. We have 7 times 7 and 5/35, and that will reduce to 7 1/7. So the combined resistance of these two wired components is going to be 7 1/7 ohms. Now again, we need to get familiar with the units, but the more important thing is when we're evaluating algebraic expressions, we want to get used to plugging in the values for the corresponding variables so we can actually get the value of the expression. Okay, let's do one more. Let's say we have the monthly cost C. We're going to define as monthly cost, and that's going to be the cost of manufacturing X amount of tires. I'm going to define X as a number of tires. So let's say we own a manufacturing plant that manufactures tires. Oh, excuse me, that looks bad. Okay. The formula for the monthly cost is given by C equals 3,000 plus 2x. Okay, so this is the expression 3,000 plus 2x, and that's how we're going to define our monthly cost C. And the cost is given in dollars. Let's go given in dollars. Okay, we want to find what is the cost of producing 2,000 tires. So we want to know what this expression is going to equal, what the cost is going to be when X equals 2,000. 2,000 being the number of tires that we're going to produce. Well, what we do is we substitute the value of the variable wherever we see the variable in the expression. So our cost C is going to equal 3,000 plus 2 times X, and X equals 2,000. So we're going to plug in 2,000 for X. And we can simply solve this. We have 3,000 plus 2 times 2,000 is 4,000. 3,000 times 4,000 is 7,000. Okay, so it's going to cost $7,000 for us to manufacture 2,000 tires, given this cost equation. Now let's find out another piece of information. Let's say we want to know what's the cost of producing 4,000 tires. So what we're going to do is we're going to let X equals 4,000. 4,000. We're going to use the same cost formula. We're going to have our cost C is going to equal 3,000 plus 2x, and in this situation 2 is going to equal 4,000. We're producing 4,000 tires. We want to know what the cost of that would be. We have 3,000 plus 2 times 4,000 is 8,000. Okay? 3,000 plus 8,000 is 11,000. So this tells us that using our cost formula, it's going to cost $11,000 for us to manufacture 4,000 tires. Okay? So what do we learn here? When we're evaluating algebraic expressions, we want to get used to inserting the given value in for the variable, wherever the variable is in the expression. And you can see that how important this is because we've seen it in finance, physics, and geometry. So evaluating algebraic expressions is extremely important because you're going to see it everywhere and you're going to actually use it in real-world situations. So we want to get used to it, we want to get familiar with it, and we want to master it before we move on. I'll see you soon.